If you would like to see the smart cooling equipment, we will now explore each bit of component you need to know about. We will see the smart cooling equipment perform and watch it work with the other components of your existing cooling equipment. Here we can see the regular operation process of a chiller. In every air-cooled chiller, the main electrical consumer is the compressor. The more we reduce the incoming air temperature into the condenser coils, the less electricity the compressor uses. If the adiabatic system is not installed or designed correctly, the coils of your chiller become vulnerable to serious damage. This is why smart cooling was designed in a way that protects your air-cooled chiller from water, dust, and other harmful elements that may damage your cooling equipment. Now, let us start with the control panel main functions. They are: number 1, to analyze ambient temperature, and number 2, to analyze ambient humidity. By using these two parameters, we calculate the right supply of water that must be evaporated to reach up to 95% of air humidification. Once this is done, it is very important to understand which chiller circuit is in operation. By installing current sensors, we can receive signals from the chiller and understand which circuit has to be supported by the adiabatic process. This second part of the analysis takes place before the adiabatic device is turned on. Next, it is essential to receive a signal from the chiller fans. If your chiller has constant speed fans, the smart cooling device is customized for the specific airflow stated in the chiller specification sheet. In case of variable speed drive fans, we are able to get the signal from the chiller board to understand at which speed the fan is rotating. In the adiabatic process, it is very important to monitor what the actual chiller airflow is and what are the ambient temperatures and humidity levels. It is only when you know all three parameters mentioned above that you are able to calculate the right amount of water to be evaporated. To supply the right amount of water is of critical importance. If you oversupply, it may lead to extensive water dripping or leakage, which might ultimately harm your chiller roof or chiller's frame. On the other hand, if you do not supply the system with enough water, the system will not be efficient. You might end up with only 5 degrees temperature drop instead of a 15 degrees Celsius temperature decrease because not enough water was used. Once the outside temperature has reached 23 degrees Celsius, the equipment turns on automatically and operates according to the parameters we have discussed previously. Smart Cooling's operational threshold is at an 80% humidity level. When the ambient humidity reaches this level, the device automatically switches off. But why does it do that? The reason the device turns itself off is because from an 80% ambient humidity level to a 95% humidity level, the difference is not significant and the device recognizes that there is no reason to be engaged. In such high humidity levels, the maximum temperature decrease that could be achieved is of just 4 degrees Celsius. Next in our presentation, we will talk about a very important point in the adiabatic process, the quality of water the smart cooling equipment uses. The system is designed to use tap water available on every building's roof or ground level. However, most tap water contains limescale or calcium molecules. In order to avoid the limescale molecules build up on the smart cooling membranes or within the smart cooling nozzles or any other smart cooling part, we place special attention on how to prevent such undesirable cases from ever occurring in the first place. Smart cooling has 2 levels of water treatment to guard against limescale buildup. The first level uses biochemical pills placed in the blue container seen on the screen. The second level is the electromagnetic water treatment. At the end of both water treatment procedures, limescale particles become a powder like fine sand and is then unable to deposit itself in the system. The particles that do come into our membranes are very fine, and every time preventive maintenance is done, you are able to wash them away easily with a high pressure water jet. Once the water is treated against limescale, it is very important to treat the water against Legionella bacteria. This task is performed by the device's ultraviolet lamp, which is adjusted for just the right amount of water passing around the lamp. This method to prevent the growth of Legionella bacteria is approved by all governments around the world and comply with regulations on how to exterminate Legionella bacteria. After the water has been treated against limescale and bacteria, it flows into high-pressure water pumps. These high-pressure water pumps are of Smart Cooling's own design and are extremely resistant, durable, and built to work in truly harsh environments. Let us consider the case of Saudi Arabia, where the ambient air temperature on a roof can reach up to 67 degrees Celsius, and tap water comes out at a temperature of up to 40 degrees Celsius. To be able to operate in such high temperatures, the water pump components need to be built from the highest grade materials. Smart Cooling's high-pressure water pumps operate at a range of 70 to 120 bars of pressure and are built to endure the most extreme conditions. Pressure levels of 70 bars are used for air-cooled chiller applications or small dry coolers, and pressures of 120 bars are used for massive industrial applications such as power plants and large industrial dry coolers employed in some refineries. A 70 bars pressure is necessary to split the water molecules into 5 to 13 microns. To illustrate the importance of this fact, let us consider the following example. Take a glass of water and pour it on a flat surface. The puddle of water will take within 4 to 5 hours to evaporate, and the temperature drop in both the room and around the puddle will be minimal. On the other hand, if you spray the same amount of water whose droplets are 5 to 30 microns, the water will evaporate immediately and the air temperature will be reduced by 5 to 7 degrees Celsius. This is why we need such high pressure water pumps. It is essential for the process to humidify the air in levels of up to 95%. Once the water is pressurized, it is distributed to the operating circuit. If both circuits are in operation, then the adiabatic mist will be supported by both circuits. In this video, we see a typical W-shaped chiller where the Smart Cooling equipment is installed. For chillers of different shapes, the design of your Smart Cooling will be customized, but the principles remain the same. Now, once the water is distributed to the pipeline, it is then supplied to the device's nozzles. The number of nozzles and their diameter are designed and calculated according to the square meters of the coil and according to the airflow of the chiller. Thanks to water evaporation, the air temperature surrounding the chiller will be reduced. And now the coils will be cooled down as they are surrounded by much colder air than the existing ambient temperature. Our next crucial point is to ensure that each water droplet never touches the condenser coil. Smart Cooling's evaporative protective membrane covers 100% of all coil surface and ensures that water droplets remain in the membrane and unable to reach the condenser coils. Past the membrane, only cold air reaches the condenser coil. This is a very important point to understand. If the condenser coils are not protected from water, they can rapidly suffer damage or decay. In this unlikely event, the condenser coils could rust within a few months. We should not neglect the importance of the evaporative protective membrane, which guards the condenser coils from dust and pollution present in the air. This is a key matter, particularly in the Middle East, where air pollution and airborne particles are a serious issue. In this environment, facility maintenance services should clean the condenser coil once a month. You should be aware that it is much easier to clean the evaporative protective membrane of the Smart Cooling device than to clean a condenser coil. The manner in which we install the membrane allows it to be mounted and unmounted very easily and quickly. And you can clean the membrane simply with a high pressure water jet. Water accumulating on the evaporative protective membrane flows directly into the Smart Cooling drainage profile. From the drainage profile, the water is distributed back into the Smart Cooling recirculation kit, where the water is recycled by 5 different filters. The water is cleaned from all mechanical dirt and then passes through the electromagnetic filter, the limescale treatment, and the UV radiation lamp. Only after this, the water is reintroduced back into the system. Each water droplet taken from the tap water has evaporated in the end. There is no waste of water. When we talk about energy efficiency projects, we talk about minimizing the consumption of vital resources, such as water. The end result can be seen here, where we have 2 similar chillers. Both of them are placed on the roof. One is equipped with Smart Cooling and the other is not. The chiller without Smart Cooling has to operate with the blistering incoming air temperature of 40 degrees. The chiller equipped with Smart Cooling is working with a cool incoming air temperature of 23 degrees Celsius. The efficiency Smart Cooling delivers to air-cooled chillers is extraordinary. Next, in this table, we can see how the incoming air temperature to the condenser coil affects the chiller performance. Let us say, for instance, that you have an incoming air temperature of 40 degrees Celsius. You can see that the electricity consumption will be of 301 kilowatts and the cooling capacity will be of 693 kilowatts. Now look at how, when the incoming air temperature is of 25 degrees Celsius, the electricity consumption plummets to only 191 kilowatts and the cooling capacity soars to 917 kilowatts. This is an efficiency increase of more than 35% on the chiller. That is why the chiller data performance sheet is a very important tool for us to estimate what will be the potential savings for each specific building or facility. We develop our calculated estimations based on the data performance sheet provided by the chiller manufacturers.